Hello everyone. So today I'm going to demonstrate the experiment number 2 of your BSc first semester lab. So let me read the object for you. So it says that you need to find the moment of inertia of a flywheel about its own axis of rotation. Okay. And let's see first the apparatus used. It says flywheel, thread, meter scale, Vernier Calipers, stopwatch and weight box. So let me first show you actually everything. So here you have the flywheel. Okay, you could see actually it could rotate. This is the axle. You find the moment of inertia of this apparatus, the flywheel, with respect to this axis of rotation. Now the apparatus, let me show you. It says flywheel, which is over here, hang to the ball, okay, of your lab. Then you have the thread, the meter scale. Let me find it out somewhere. So here is the meter scale. I got the meter scale here. Let me put it with me. And then the next thing is the Vernier calipers. Let me see where it is. I got a Vernier calipers as well, as you could see. Okay. Next thing, there are some other things like, for example, stopwatch is out here. Okay. Then the next thing is the weight box. I've got this weight over here. In fact, I got two different weights rather than having the full weight box. So let's see what we need to do. Well, before doing anything, we should first check the formula used over here. So it says that the moment of inertia of the flywheel is 2 times mass acceleration due to gravity gh, height of the thread, minus mr square omega square, and then omega square 1 plus n1 by n2, where omega is given by 4 pi n2 by t. Well, let's check actually what are all those things. I is obviously the moment of inertia of the flywheel that you need to find about the horizontal axis shown over here, right? Of rotation. And then the m is the mass suspended at the end of the thread or string. So masses are here. In fact, this is what we will suspend through this thread. Okay. R is the radius of the axle. So this is the axle. We need to measure its radius. H is the height through which the mass m falls on the ground. H2 minus H1. N1 is the number of the turns of the thread wrapped around the axle of flywheel. Number of revolutions made by flywheel before the mass m is detached from the axle of wheel. N2 is the number of rotations made by the flywheel before it comes to rest after the mass is detached, right? So what it says that when your mass is attached, you should keep counting the number of oscillations until it drops off fully to the floor. And N2 is the number of rotations made after the mass drops and the flywheel comes to a full stop. So those should be the number of rotations N2. Third thing is T. Time taken by the flywheel in N2 rotations. G is acceleration due to gravity and omega is the angular velocity of the flywheel. Right? So let's see how we perform this experiment. As I said, you could read actually all this procedure, but I can simply tell you what it says in a nutshell. You would first take a weight, attach it with some thread over here, okay, and then hang it to, essentially suppose this is the, so I'm just taking the thread, okay. So I would just take this thread, suppose it is here, please bear with me while I'm taking this weight. Now what I'm doing, I will attach it with this. I will have to hang actually this weight, right? So here is how I hang this weight with this thread. Just wait a moment, I'm still doing actually all those things just to show you that things might, well, it takes time while I'm showing this, demonstrating this experiment, recording this experiment, demonstrating it to you. I have to in fact do all those things. Okay, so here is how I had attached my weight. Now what I will do, I will hang it with the flywheel, wrap it first. Okay, so I will, you could see actually here we have something through which I can tie my weight, right? I can simply tie, and then what I will do, I would simply wrap it around. You could see, in fact, I'm wrapping it around. So, well, this is not the correct way, but it is just to demonstrate, okay? So I would wrap it around properly so that the whole weight is wrapped until the weight comes to its axle, okay? So you could see I'm still wrapping up, keep coming, the weight is keep coming. You would see that it is rising, shortly it should come up. Still going on, you could see the weight is out here, rising up and up. So now I have the whole weight. So what I have to do now, okay? So you could see, now I will leave. So now I will switch on the stopwatch, and so here you could see, this is the time when I switch. I will hold it like this, switch on the stopwatch, and then I will let the weight fall, okay? So now it will fall. I will keep counting the oscillation, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 oscillation, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26. So this way, as you could see actually, it is still not at a stop. You should keep counting actually these oscillations, N2, until the flywheel stops, right? N1 is the oscillation counted until the weight drops to the floor. And as soon as the weight drops, from there you should start counting 1, 2, 3, 4, 5. Those would be the oscillations N2 until this flywheel comes to and stop. So you got N1, you have got N2. Time taken is still being recorded, T. Okay, so now what you would do? You would fill those entries over here. As you would see, here I have this weight, serial number, M mass is 100 gram, N1 is the reading with the weight, and these are the oscillations until this weight get detached. Okay, that is, it unwraps until the whole length. Then you would record N2. So you should have actually 2 or 3 observations for each of them. This is the time until the flywheel comes to and stop, starting from the detaching point. Time recorded for N2. N2 mean T, and then the height actually, that is what you need to measure. So you should actually either measure this height of the thread that you had used, okay, from where you hang. So either you should measure that height beforehand, or you could have it before wrapping, or you could in fact do it after it falls off. Okay, so that's the height. Similarly, you could do for other weights, for example 200 grams, 300 grams, and so on and so forth. And after that, what you will get? You will get different kind of moment of inertia for different sets of weights. Okay, so those things you could obtain through this formula. M are the weights. Radius, by the way, how to measure the radius, that is still left. So let me show you how to measure the radius of this axle of the flywheel. Well, you know, you have this calipers. As I always say, you should record its least count before any reading. Okay, so you could see actually This is 1 centimeter and you have 10 divisions over here, so you have 0.1 centimeter as the least count. So now what we will do, we will measure the diameter of this axial around 2 of its length. One length could be on, say for example, this side. Okay, just record it over here. That is your length, as you could see over here. Okay, read that reading. The main scale reading shows here is 1.7, and then check actually what meets. I think this is the 7th. So 1.77 is the centimeter is the reading. And then what you, so this is along one axis, then you rotate it by 90 degree. Okay, so this way, one reading here, another reading, I'm sorry, at 90 degree. Okay, so these two readings you should put. So reading, let's see what it says, and you should have actually several of these readings. Reading along any diameter A, reading perpendicular to that diameter, that's B, take the average, that's capital D, and the mean radius would be simply the diameter by 2. So you should have 2-3 of these readings. Finally take the grand mean, that's going to be your radius of the axial. Okay, so we got the mass, we got G, we know the height, RB is also known, omega is 1 over 2 pi by T, and you know the N1 and N2. So put all those values in, and that will give you the moment of inertia for different sets of mass, and ultimately you take the averages of all three. That would give you the moment of inertia of the whole flywheel. So this completes the experiments, and as you know, due to this COVID period, I will be supplying all the observations taken by us at the classroom. You need to in fact perform all the calculations, find out the moment of inertia, and submit those things in properly after writing into your practical notebook at the classroom of your group. Okay, so thanks a lot.